let's go ahead and get started. So thanks for joining Scaling PHP in the Real World. My name's Dustin Whittle. I tend to talk very fast, so if at any point you want me to slow down, just say so. Also, I like to keep it pretty casual, so if you have questions along the way, don't hesitate to just shout them out or raise your hand. So you can find out more about me at dustinwhittle.com or follow me on Twitter at dustinwhittle. I've worked on a lot of PHP projects in the past, so my current role is developer evangelist at a company called AppDynamics. It does application performance monitoring for PHP. Before that, I was doing consulting and training at Sensio Labs, the creators of the Symfony framework. And then before that, I brought Symfony to Yahoo to rebuild Delicious and Yahoo Answers. So I have a bit of experience when it comes to PHP. So how many of you are aware that Facebook, Yahoo, Zynga, Tumblr, Etsy, Wikipedia are all started on PHP? There's a lot of pluses and minuses to building on PHP, but today I'll talk about how you can scale it. So these aren't very in-depth. What you won't find here are code-level examples of how to apply all of these, but these are good strategies that are pretty much universal. So why does performance matter from a business perspective? Microsoft found that Bing searches that were 2 seconds slower resulted in a 4.3% drop in revenue. So it really affects the business. And when Mozilla shaved 2.2 seconds off their landing page, Firefox downloads increased 15.4%. So 60 million additional downloads just because the site was a little bit faster. And when Barack Obama's website had a 60% faster increase in adoption, was 60% faster, they increased adoptions by 14%, or $30 million. So just because a website is fast, there's going to be more users who use it more often. And anytime Amazon or Walmart can increase revenue by 1% for every 100 milliseconds of improvement. So this is true for Amazon, AOL, Yahoo. Every serious web company treats performance as a feature, not as an afterthought. And if you're a smart developer and performance directly impacts your business. So again, what does good performance look like? Well, how fast, when a website's slower than 3 seconds, 57% of users will abandon it. But how fast is fast enough? So 100 milliseconds or 0.1 seconds feels instantaneous. It feels like you're flipping a page in a book, right? 1 second allows you to think seamlessly. After 3 seconds, you start to stray. Users lose focus. And after 10 seconds, people start to abandon your site. They also lose confidence. If you click on checkout and it takes 30 seconds for your order to process, you're losing confidence in the site. So PHP is slower than Java, C++, Erlang, Scala, and Go. But there are a lot of ways to handle high traffic applications. How many of you are familiar with phpsadness.com? Right. So PHP does have a lot of quirks and design issues, but the reality is PHP is never going to be your problem. PHP at its core is generally very fast. By a show of hands, what version of PHP do you run? How many are on PHP 5.1 or before? 5.2? 5.3? 5.4 or newer. And just out of my own curiosity, who's running on 5.5 already? All right, a few. Okay, so if you're not on 5.3 or above, it's time to join 2013. It was released a decade ago. At this point, it's time to upgrade. You've had enough time. It's supported on every major distribution. I'm a big fan of the Nginx and PHP FPM setup. So Apache and Mod PHP works quite well. It's the default. It's available on pretty much every distribution. Working on a lot of PHP projects, PHP, FPM, and Nginx are a lot more configurable, so you'll get a lot more performance out of them. I highly recommend if you're running PHP, you should be using Nginx and PHP FPM. PHP Fast Process Manager. It's a CGI interface to PHP. So essentially, it's individual processes are running underneath. So Nginx just hands it to a socket, which gets processed. But what's nice about this is you can better configure how those processes are managed, right? So in Apache and Mod PHP, it's basically per thread, or well, not per thread, but per process of Apache instance underneath is matched by a PHP embeddable. And in PHP FPM, they're completely independent. So it means you can configure how does Nginx handle HTTP connections, and how does PHP process each request. So it's more tunable for performance needs. So everyone here should use an opcode cache. If you're not, you're missing out on a huge performance gain that costs nothing to implement. If you're familiar, PHP 5.5 has Zen's op cache by default. But anything before that, I highly recommend APC. So I think Rasmus is running around here somewhere. Rasmus, creator of PHP, also works on APC. It's an opcode cache for PHP. If you're not using it, you should. Essentially, the way it works is PHP, every time it loads a request, it reads the file, interprets that file, and then caches that opcode. So the next request, instead of having to read the file again and interpret it again, it can just use the cached opcodes. It's pretty straightforward. Peckle install APC is really easy to do. There's also IonCube, Zend Optimizer, Xcache. There's a bunch of them. I highly recommend APC. It's something that just works out of the box. So this one's a little more controversial, but I highly recommend using autoloading. So how many of you are familiar with autoloading? Okay, so in PHP, when you want to include something, you have to call include or include once or require once. With autoloading, you can specify an autoloader for, you can register an autoloader, which basically says how you can load PHP classes. So how do I discover them? There's a PSR 0, which is a standard for how do you map files to an autoloader. If you're not using it already, there's a Symfony 2 component that makes it very easy to drop into any existing PHP project. So the Symfony 2 class loader component also allows you to cache the class map in APC for an additional performance gain. One other pro tip is each file that you have to include has some performance overhead because you have to touch the file system to read it. So another optimization is you can aggregate all of your class files into one gigantic file and include that once. So if you use something like Symfony 2, when you use Symfony 2 in production mode, it does this automatically for you. Okay, so PHP is very easy to scale. How many of you run a website with more than one server? How many use only one server? Okay. So when you want to go beyond a single server, really the only thing you need to tweak in PHP is the sessions. So when I go to one server, how can I have the session data persist and make it available across multiple servers? The default strategy in PHP is to persist session data to disk on the local file system. As soon as you add another machine, it doesn't know how to find those files. So it's going to create a new session, so there you lose state. So HTTP is stateless. The way you persist state is through cookies and sessions, or sessions is the vernacular in PHP. But again, the default is to persist session data to disk. Even better is to store session data in a database. So this is very easy because now I can just make a request to MySQL from any one of the web servers and access session data. But even better is to store session data in a database and front it with an LRU cache, or least resource used cache, like Memcache or Redis. So first I'll try to look in Redis to see if I have fresh session data. If not, I'll make the additional request to the database, run a SQL query, get the session data, and put it in the cache, and it's a much more performant strategy. But the best strategy I found is really to optimize your session size, so make your sessions as small as possible, and put them completely in a cookie. The way PHP works by default is you create a PHP session ID, and that's what gets persisted to a cookie. But the session layer in PHP is very easy to adapt. So the best strategy is to essentially create a signed or encrypted cookie, so that if you know that you can check the signature or you can decrypt the data, that it hasn't been tampered with. So I can put all of my state in an HTTP cookie. This is what Yahoo, this is what a lot of major websites do. The downside to this is that cookies have a size limit, which is about 4K. And the problem with this is that if the cookie ever gets beyond that, the browser will fail to register the cookie at all. Or it will only have part of the data, which means the signature won't match or encryption won't match. So getting beyond a single server is quite easy. You just have to optimize your sessions to either use a database with a cache in front of it, or put everything in a cookie itself. So how many of you use an in-memory data cache today? How many of you have heard of Memcache or Redis, or use Memcache or Redis? All right, so if you're not, you should. So find out more at memcached.org or redis.io. So there's a bunch of different use cases for where an in-memory data cache is very useful. So any data that is expensive to generate or query and is long-lived should be cached. So good examples are web service responses. If you're interacting with a Twitter API or Facebook API or any sort of third-party service, you don't need to make that. A lot of the times you don't need to make that request every time a user shows up. So what you can do is you can put it in Redis or Memcache for a period of time. If it's still valid, it'll go directly to Memcache or Redis. Otherwise, it'll make an HTTP query. So any HTTP response, database result sets are another common thing, and any configuration data. So instead of generating it or reevaluating it every request, you can simply pull it from the cache. How many of you have heard of Guzzle? All of you? All right, so Guzzle is an HTTP client that has built-in support for caching web service requests. So if you're familiar with curl, it's horribly designed, but is what most people use to make web service requests. Guzzle provides an abstraction on top of that with a ton of features, like support for caching in Memcache or caching in Redis. The same with Doctrine. How many of you use an ORM? By show of hands. How many of you use PDO directly? How many of you are still using MySQL Connect? That is the right response. Don't do that. At a minimum, use PDO. If you want some object-oriented structure on top of that, you can use Doctrine. Propel's another good ORM. I highly recommend Doctrine. It also has support for caching built in into Memcache or Redis. And it makes it very easy to automate putting stuff in the cache and getting stuff out. So really you only say, I want to select star from post, and you give it a timeout, an expiration, right? And if that expiration is not met yet, it will go directly to the database or pull it from the cache. So it's pretty straightforward. Here you make a request, it goes to the web server, checks the cache. If it's not in the cache, goes to the database, puts it back into the cache, and then returns the response to the client. This works for HTTP requests. This also works for any database request. All fairly straightforward. So one of the biggest ways to improve performance, or decrease latency rather, is to do blocking work and background tasks via queues. So there's a lot of really good solutions to this. I'm going to focus on one in particular. So if you download the slides, which are already available on speakerdeck.com, you can get a lot of notes at the bottom of these slides that will give you more details on how to get started and really how to practically apply all of this advice. So I'm going to talk about Rescue. So Rescue, Gearman, RabbitMQ, Kafka, BeanstalkD, ZeroMQ, ActiveMQ all solve similar problems. But really the result here is I want to put something in the background, not block the user's request, and process it. So I'm going to talk about Rescue. So Rescue is written by one of the GitHub guys, I think defunct. I can't remember his real name. They originally wrote it in Ruby. It's been ported by Chris Bolton to PHP, and it's a really straightforward way to implement background tasks with queues. So what should you queue? Anything that would block a user's request that the user doesn't need to have in the response. So common examples are sending notifications or posting to social accounts like posting to Twitter or posting to Facebook, analytics and instrumentation, updating profiles, discovering friends, consuming web services or like Twitter streaming API. And the reason for this is all of these things take a lot of time, but in order to show the user the next page, I don't have to have the response yet, right? I don't need to know that the Twitter post was successful in order to show you that you've shared some content. I know it's in a queue, I know it will get processed, I know if it fails, it will get retried. So what does this look like traditionally? A user submits a form, I have to update the database, I have to refresh the cache, I might send some emails, send some notifications, and then recommend some new friends. All of this takes 3.7 seconds. By the way, all of these images and slides are stolen from awesome open source people. Attributions at the end. What does this look like after? So in order to show the user a page, I really just need to update the database and submit an order, or create some additional tasks that happen in the background. And the difference is before, I had to have the user wait for all of these things to successfully finish, and all of that took 3.7 seconds. When I use background tasks and queues, I only have to wait for me to update the database, and then I can create a task to do all of these additional jobs. And all of these will run in the background. And in this case, the user only waits 300 milliseconds. So there's a performance advantage. You minimize the latency. But even better, you increase the scalability because now each one of these tasks lives in a separate queue. And I can scale each one of them independently. So what this looks like is I have a queue. In this case, the queue here is going to do some basic tasks like refresh the cache, send mails, send notifications, and recommend some friends. And then I have a second process that's sending emails and generating thumbnails, or some additional task that needs to be done in the background. Each one of these can have workers associated with it, where essentially I insert a job into the queue, The worker pulls the job from the queue in the background via PHP command line task, executes the jobs concurrently, and they're finished. Now, traditionally, this looks like this. I have a class that has a bunch of different methods. Do this, do that, do foo. Each one of these methods gets called, and I might have a controller, and inside my controller action, I call each one of these methods. So I have call, function, do this, do that, etc. from my controller. But with background task, I simply want to create a job for each one of these and insert it into the queue. So what that looks like is I have rescue. Rescue provides a method called enqueue. And now I want to enqueue into this particular queue, this worker, this task. So do that, send an email, send notifications, discover friends, etc. Rescue is very straightforward. I have a PHP method. I want this to get run in the background, and I want to put it in a simple queue. It's pretty straightforward with background jobs. I'm going a bit fast, but we'll work it out. Any questions so far? All right, so how many of you use... It's backed by Redis, so it's pretty fast, but also it's extremely easy to explain. It's very straightforward. I have a PHP method. I want you to run this method in the background. Traditionally, I use RabbitMQ. RabbitMQ is a lot more work to explain. You have to explain AMQP. That's usually why I go with Rescue. It's also, if you're just getting started, it's what I would recommend, so you can get familiar with the concepts. And then once you need something more advanced, you can iterate from there. So, how many of you leverage HTTP caching today? How many of you are familiar with HTTP caching? How many of you do something in the client side? Like, how many of you know JavaScript? How many of you work with CSS and images? Very practical advice is to make images, CSS, and JavaScript have a far futures expires header. The expires header is essentially HTTP caching, right? You're basically saying, I don't want to request this. I don't want to make another request for this asset until this time. Well, you can do the same thing on the server side. So for a lot of content, you actually don't need to generate the content every single request. I only need to generate that content when it's invalid or it's expired. So in this case, I'm using some AWS vernacular here, but I have a load balancer. Behind the load balancer, I have some Varnish instances. Behind the Varnish instances, I have my app server. So this is PHP. And then PHP might be talking to Mongo or Redis or MySQL. And then I have my background task running workers also talking to a variety of services. So traditionally, HTTP request and response looks like this. So Alice shows up and she requests /welcome. It goes to the cache. This is the browser cache or server-side cache in this case. It says, do I already have a copy of /welcome? If not, let me go directly to the server and request /welcome. That returns an HTTP response, which is essentially hello world in this case. Returns HTTP response code 200. Goes to the browser cache if it has an expires header or a validation header, and then gets returned to the client. So this is without caching what every request looks like. Make an HTTP request, goes to the server, responds with an HTTP response. Now generally there's two strategies for HTTP caching. Mark Nottingham has written a really great guide to explain caching. These are Ryan Tamako's slides as well. Most of the graphics come from him. All of these notes are in these slides on SpeakerDeck, so feel free to follow up and really go through there. But I'll give you a rough guide today. So there's expiration. Most people are familiar with HTTP caching, the expiration model, or expiration strategy rather, when it comes to CSS and JavaScript assets. Because one of the common advices is to give it a far futures expires header, and the browser will never make a request for that CSS or JavaScript until a time has passed. So what this looks like in terms of HTTP response codes and flow, I make a request for /welcome. It's not available in the cache, so it's going to make a request to the server backend. And it's going to have hello world with a max-age header. So the way the HTTP caching specs, the HTTP spec works is you have cache control headers. So I have max age, expires, and a variety of others that we'll walk through. In this case, we're just going to say max age. So I have a cache control header with max age of 600 seconds. So don't request this resource again until 600 seconds has passed from the last time you've got a copy. This is fine when I have a home page, and the home page only ever gets refreshed when I add new content, or at most I add new content every 5 minutes or some defined period of time. expires works quite well. So the first request looks like this. I request /welcome, I get /welcome from the server with a cache control header of max age 600 seconds. It returns to the browser. Now, somebody else comes along and says, I also want /welcome, or the home page, or whatever URL you prefer. It's going to live, this is the varnish layer. It sits in front of your server, so this is Apache or Nginx and mod.php or PHP FPM. You have varnish in front. So varnish is going to keep a copy of that HTTP response, and it's only ever going to return it if this max age is passed. So because I say the max age is 600 seconds and the current age is 30 seconds, it's going to return it right away. So I've saved the back end HTTP response or a request, right? This alleviates a ton of load on your application servers. And for most applications, it's very easy to configure cache control headers and just say this expires in some amount of time. Any questions? So the next strategy is validation, and this is much more practical. When it comes to dynamic content, it needs to expire, you need to invalidate it. So I might have a blog post, and a blog post has associated comments. I don't ever want to serve a stale blog post because somebody has added an additional comment, but the content hasn't expired yet. So in this case, we have the validation strategy. Essentially, the validation strategy does something similar. Alice comes in and asks for /welcome. I request /welcome from the server because it doesn't have it in the cache yet. I return an HTTP response with a last modified date and an E tag. So an E tag is essentially a unique identifier for a particular resource. And then the last modified date is when was the last time this content was updated, right? So I have a blog post, and a blog post has associated comments. The last modified date would be the last time somebody added a comment. And then the E tag might be an MD5 of the blog page URL and the number of comments. There's a bunch of different strategies you can use for this. In this case, it goes back to the cache with an E tag, the last modified header, and that gets returned back to the user. Now the next user comes along and says, okay, I want to get /welcome. It says get /welcome if modified since some date, or if none match some E tag value. So I've requested this page in the past, and I have some state now. I know that this is this MD5 or this signature for this particular unique resource. And I have this if modified since. So if this date has passed, or if this content has changed, I want to make an additional request to the server. In this case, what you're going to do is generate validators. So you're still going to make a request to the back end, but the only thing that the back end has to do, the only additional application logic, is to determine whether the content is still fresh or not. So it's a lot easier to do a SQL query for the number of comments on a blog post than it is to render the entire blog post content, right? So you've saved yourself the additional load of having to render out an entire page. Here what we're going to do is just generate validators. So in this case, we're going to say, okay, the content hasn't changed. This is the E tag still valid. We're going to send an HTTP response code 304, which means it's not modified. Nothing's changed. If that's the case, it's going to simply return it back to the cache and respond back to Bob with this /welcome response. Now this is a very common approach that works really well for a lot of content, but sometimes you need to mix and match both expiration and invalidation. So in this case, we have /welcome. We're going to go to the cache. Varnish doesn't have /welcome in the cache, so it's going to make a request to the back end. It's going to turn that off and generate some validators. Casual, but not that casual. So we're going to take cache control headers. We're going to say, okay, there's a max age. So this content's valid for 300 seconds. And it was last modified on this date. Or in this case, the max age is 60 seconds. That's going to be persisting the cache for 60 seconds or until this last modified date happens. Now, the next user comes in. Bob requests the same page. It goes to the cache and says, okay, the max age is 60 seconds. This content is only 30 seconds old. So I'm not even going to ask the back end to validate the content because this time period has not passed yet. Right? Now, the next time somebody else comes to the page, the max age has already expired. So it's actually going to make a request to validate from the back end whether the content has been updated yet. So we're going to generate validators. In this case, it's just going to simply validate the E tag. Is it still valid? Has the content changed? If not, it's going to send a 304 not modified with a cache control of additional 60 seconds and be served back to the user. So this is a really easy way to have, if you have some dynamic content on a home page, but you also don't want the homepage to ever be refreshed more than every 30 seconds. You can apply both strategies. There's a variety of servers that you can use to accomplish this. Both Nginx and Apache have modules or extensions to do this. So Nginx has the proxy cache. Apache has a proxy cache as well. Traditionally, there's Squid. I highly recommend Varnish. It's extremely fast. It can be spread across multiple machines. So any questions about caching so far? Go for it.
All the
So one of the nice things about Varnish is it supports what they call edge-side includes. So to answer your question, yes. Traditionally, you can capture the entire HTTP response and put that in a cache. But there are some times where most of the page needs to be cached except for this one module. And I want you to check whether this one module is valid or not, like one part of the page. For that, you can use edge-side includes. So not all of these services have support for ESI, but Varnish in particular does. What that means is I will cache the entire page except for one segment, and in lieu of that segment, I will have an ESI:include tag that says where I can find that resource and how long it's valid for. So if I want to cache 90% of the page, but I only want to have, say, refresh the top 10 headlines, I can use an edge-side include for the top 10 headlines and cache the rest of the HTTP response. So instead of making another request to the app server, so instead of making another request to the back end for the entire page, I'll say, okay, I have this part of the page in the cache, but I need to request just this module. So the processing power required to generate just this module is a lot less than it is to generate the entire page. So edge-side includes can save you quite a lot of processing on the server side. But you still have to make an additional request, right? So instead of requesting /homepage, I might just request /top 10 headlines. If you want to use edge-side includes and you want to use Varnish, I highly recommend Symfony. Not only because I'm a part of the community and worked for the company in the past, but also because it has a HTTP cache client. The HTTP Foundation has support for caching built in, and it also has support for ESI includes. So if you use Symfony 2 and you use Twig, by a show of hands, how many of you have used Symfony in the past? Okay, so quite a few. And how many of you have used Twig with Symfony? All right, so pretty much everyone. If you use Symfony 2 and Twig, every time you call a render tag, you can pass in standalone true, and what that will do is turn it into an ESI tag if you use HTTP caching. So find out more at symfony.com caching, but you can drop this component into any PHP project and start leveraging this stuff right away. So the entire application doesn't need to be Symfony 2. You can simply drag in the HTTP Foundation component and start using it. So Symfony just provides the ESI include tag as part of the templating system, but Varnish is what does the actual processing. So Varnish is going to say, okay, I have this cache content. Inside of this cache content is an ESI include. Now I need to make another request to the back end to get that data, and then I'll stitch it together and serve that to the end user. But this works quite well. You can have multiple ESI include tags and content. So if you want to have 3 sections that are dynamic and the rest is cacheable, that's possible as well. But yeah, that's highly recommended. It greatly depends on how computationally intensive it is to generate each one of those pieces. So one of the things I'd like for Varnish to add is the ability to fetch ESI tags concurrently, which it does not currently do. That would improve that performance in a case, because instead of making requests serially one after another, I can just say, send all 5 of these, get all of these back at the same time. All of these, the goal of all of the HTTP caching is simply to alleviate the load on the application server, so I can get more throughput by having cached content, right? Your mileage may vary. It greatly depends on how the application is designed, how cacheable the content is, and that also depends on which strategy you use, expires versus validation. Sometimes going to the back end to generate the validators to validate the content is still fresh is just as expensive or almost as expensive as just generating the entire page again. In that case, is it really worth it? You probably spend more time dealing with the cache in the back end than you do just generating the response. But it highly depends on the application. Any other questions?
What happens if we have several instances of varnish? They work together, or we need to have just one and they balance the load of the server?
There is a way to configure them to share a data store, and as I understand it, they now offer varnish replay. You can use, basically the goal is to use a centralized data store. Traditionally, if you download Varnish, it's one Varnish instance per machine. But one Varnish instance can handle 10,000 concurrent connections, so you get significant throughput using just one instance. If you exceed that, then you need to have a shared data store underneath, or you have to end up managing the cache independently for each instance, which is a gigantic pain. So, and when I want to invalidate the cache, say the home page is now expired, it's only expired on this one machine. What I need to do is delete the data across all of my machines in the cluster, right? So they're adding features for this. I'm not sure 100% where they're at, but it is possible to use a shared data store. Anything else? Yeah, but that's, so each varnish talks to itself, but underneath it has to look somewhere for the data, right? So that's the shared data store. So each one of these is going to be a varnish machine, and I might put like 5 varnish instances behind a load balancer. It just depends on which instance it hits. Each one by default will have a cache that lives just on that box, just for that instance. So what he's talking about is every time I go to the load balancer, it randomly selects which varnish instance I'm going to talk to, and that might have a separate cache than another one. The way to solve that is to give them all the same shared cache underneath. There's a variety of approaches. And when you use that, generally what I've done is Nginx proxy cache has a memcache backend, which does something very similar. So I can have a bunch of Nginx instances behind a load balancer using the proxy cache support with a memcache backend. And it doesn't matter which Nginx instance it gets hit, it'll still read the data from the shared memcache instance, or Redis, whatever you prefer. And that solves that problem quite well. But it's not, so Nginx doesn't have support for ESI includes by default, so each one has trade-offs. I believe there's a module for it nowadays, but not 100% on that.
But that shared physical data for varnish,
so a very bad approach to this would be to do a network file system underneath where all the machines share that, but then you have a different problem, right? You have network I/O that is going to be your issue there.
If we do it with Nginx, we move the system, and the first is going to be first load, so for example,
well, the first request is going to be for the home page, and all that's going to do is pass it to PHP FPM to say generate this response, and then that will be inserted into memcache. It's the same here. The first request, I'm going to get, there's going to be nothing in the cache, so I'm going to have to go to, actually, here. Yeah, so the first request, /welcome, or the home page, whatever, is going to go to the cache. There's nothing in the cache, so I need to go to the back end, and then I need to generate the actual response. Then it's going to be put inside the cache, and then the next request, here we go. The next request, it's going to be in the cache. It will just be returned directly from that. So you're right, you still need to prime the cache, right? There's still the original request, which is going to be expensive, but it's no different than running without a cache to begin with. Anything else? All right, so a lot of this is practical advice. None of this is really specific to PHP. I mean, the idea of putting background tasks in queues and operating from queues, the idea of using HTTP caching can be applied to any language and any technology stack. For here, really optimize your framework. I can't tell you how many projects I've walked into where they had every feature turned on, they weren't using any caching whatsoever. Depending on your technology stack, all of these systems have some optimizations built in, but you need to be smart enough to turn them on. So almost all of them support, one, stay stable, just like with PHP. If you're running an aging version, there's usually performance improvements, security improvements, feature improvements in every version. Disable features you don't need. So a lot of times internationalization is turned on by default. You might have a security system or ACL system that's enabled by default. You may or may not need it. evaluate the specifics of your application, and then adjust each framework adjust each framework accordingly. Always use data cache, memcache, or Redis. Pretty much all of these support memcache or Redis out of the box, both for data cache as well as for an HTTP cache. And then always try to use an HTTP cache front end or reverse proxy cache like Varnish or Squid or Nginx proxy cache when you can. So usually the problem is not necessarily the throughput on the web servers, but once you get to a certain scale, you exhaust the throughput on your database backend. So solving the problem of being able to do SQL reads is very easy with adding multiple slaves. So I have one master, I can add additional slaves. With every additional slave that I add, I get additional read throughput. But at some point, you max out your write throughput. And once you do that, generally your option is to buy bigger hardware. And therefore you get more throughput. This works for a while, but at some point you have the biggest machine you can buy and you're still maxing out your throughput. So what do you do then? So sharding. Sharding, I'm going to give you a really simple explanation here, but it's basically taking a large problem and making it into smaller, manageable chunks. So I might have had 3 separate databases before with users, images, and comments. And now what I want to do is, in my ORM layer, or my database abstraction layer, I want to break down which database I talk to for which data. So in some cases, and this is a very simple implementation, it's not what I'd recommend in production, but you can break down your users into 3 different databases. So I might have users that start with A through H in one database, which I can now put on one piece of hardware, and then I can do that 3 times over. So A through H, I through S, T through Z. This is a very simple sharding strategy. If you use Flickr, they use actually something similar but more complicated. Basically, all this user's data lives on this instance. And before I was exhausted by whatever size instance this was, I can now add multiple shards. So I could break this down even further. If I max the write throughput on each one of these instances, I can simply add more database machines and make the shards smaller. So users A might have a database for just users that begin with the letter name A, etc., B, C, so on and so forth. So usually if you've gotten to this point, you have the engineering talent to solve this problem, or you should have a successful business underneath. But this is a really simple strategy. Doctrine has support for sharding out of the box. And I believe Capel now has it as well. So if you get to this stage, there's a couple of different options. But it's really about taking what was a very large problem and breaking it down into smaller, more manageable chunks. More and more I'm seeing service-oriented architecture. So I have a REST API. I have written in Java, Scala, Erlang, Go, Node, whichever you prefer. And then on the front end, I have PHP, or nowadays pure JavaScript, like Backbone or Ember or Knockout, whatever you prefer, Angular. Once you hit a certain scale, you really need to design with service-oriented architecture. Everything needs to be completely independent and fault-tolerant, right? Eventually, companies of great scale end up moving away from PHP, and they end up rewriting certain computationally intensive aspects of their program in a lower-level language, like Java or Erlang or Go. Again, companies of great scale tend to move away from PHP or adopt PHP or tweak it, or in Facebook's case, completely rewrite an interpreter. So at Yahoo, we had YPHP. The notion of YPHP is just Yahoo's version of PHP. But what they did that was unique, and what a lot of companies do nowadays, is anything that's computationally intensive, you just write as an extension, right? PHP has a fairly, well, maybe not sane is the right word, but they have an API for creating extensions in C++ or C, and then just exposing them to PHP. So if you have CPU-intensive code, computationally intensive code, that is a good strategy that will buy you quite a bit. Once you exceed that, like Facebook, Facebook has built HipHop. So version 1.0 of HipHop was basically a transform PHP into C++. And the goal is for pure performance. HipHop 2.0 is really a virtual machine runtime and just-in-time compiler for PHP. And I believe there's a Facebook person in the audience who's going to be doing a talk about it. But once you hit a certain scale, you really need to make the language more efficient. But in order to do this, you have to have the engineering resources to make it possible. So they can only do this because they have enough money that if they save themselves 100 servers, that's a data center that they've saved. But I would check it out. I think there's a website, hiphop.org or something. Yeah. But the goal is essentially to replace PHP. There's a lot of problems with this approach. They've really tried to open it up recently. I think that there's a big push for them to support the Zend extension API. The biggest limitation nowadays is the support for extensions. So a lot of common functionality that you expect in PHP just doesn't work out of the box. This works for Facebook because they confine their developers to use only the supported APIs, and they have a lot of resources put in rewriting this. But more importantly is learn how to profile your own code for performance. So how many of you are familiar with Xdebug? All right, there you go. So there's Xdebug, which allows you to do profiling. You should never really use it in production, but it's great for a development environment where you want to figure out where's the time being spent. So Xdebug will give you cache grind files or val grind output, which essentially you can drop into a web grind, which is a UI for these outputs. And what they'll tell you is where are you spending the time, like how many milliseconds and how many calls, like how many function invocations are being made for this particular page, and how much time does that take. So you can really get a good idea of where to focus your time. If you do need to run in production, there's xhprof, which I thought I had a slide for, but I don't, and xhprof GUI, which is lower overhead, and essentially does the same thing. What's causing performance problems? And then the company I work for is called AppDynamics. They do application performance monitoring in PHP. So we'll map out your application, we'll tell you where the traffic's coming from, and when you have performance problems, we'll tell you exactly down to the down to the line of code what the problem is. So you can figure out, okay, what exactly has gone wrong, as well as any third-party requests like web service requests or database requests, and see exactly where performance is being impacted. So the biggest thing with applications nowadays is most of the time is actually spent on the client side. The 100 milliseconds, the 200 milliseconds spent on the server side is nothing compared to the second waiting for JavaScript and CSS assets to load and for the DOM to render. So in modern web applications, most of the latency does come from the client side, so you should also focus on that. Google has done a great job with Google PageSpeed. So Google PageSpeed has PageSpeed Insights. Essentially what you can do, how many of you are familiar with Firebug and YSlow? All right, everyone. So Google PageSpeed is basically the next generation of this. You can put in a URL and it'll give you some suggestions for how to improve the client side. Like decrease the number of requests for JavaScript, so minify and concatenate all the JavaScript. Optimize your CSS selectors, etc. It's also available in Chrome. But even better, how many of you use continuous integration? Like Jenkins or Travis CI or something like this? So they have an API that makes this really easy to do in an automated and repeatable way. So it's pretty straightforward. Curl the URL, and we'll give you a JSON response of here are the recommendations for how to improve the client side. So scalability is really about the entire architecture, not minor code optimizations. And I think that's the biggest key. It's not about single quotes versus double quotes. All that stuff is fixed by the compiler. And it's really about the entire architecture. So applying basic design principles like queuing, like caching, is how you're going to get more performance and better scalability. And that's all I have. Any questions? Let's not have everyone yell at once.